tangent slopes first. So tangent slope is just finding the what? The first derivative. So if I don't give you a coordinate of the tangent slope, so if I ask you for the general tangent slope, that's the first derivative, correct?
Yeah.
If I ask you for the tangent slope of the specific coordinate, this is what it will look like. So I'm going to give you this equation. Y equals 4x minus 3x squared. I love when it does this. It just makes me so happy. Okay, just that for now. All right. I want the tangent slope. So what am I asking you to get? The first derivative. So we're going to find y prime, and this is way easier than the ones we practiced. So what's the derivative of 4x? 4, because it would be x to the 1. The 1 would drop in front and become x to the 0, and it would go away, correct? And then this would be negative 6 x to the 1. So we're done, right? So what we can say is we can call this m tangent. Go away, little blue box. M tangent is 4 minus 6x. Now, guys, that is the general slope tangent for every single tangent on the graph of 4x minus 3x squared. Yeah. It's where it touches in one spot only, which is what we're going to talk about in a second. So what I want you all to do is to accurately sketch. I'm going to bring around a sticky note. It's not just a sticky note. It has a grid on it. I'm going to bring a sticky note around with a grid on it. You're going to accurately sketch the graph of the original, 4x minus 3x squared on it. Okay? There's our graph. Now, I can give you any coordinate on this graph. I can give you a decimal coordinate. I can give you a full coordinate. I can give you any coordinate and ask for the tangent slope of it. Why are you looking at me like that? Okay, we're going to use a coordinate. The one I'm going to ask for the tangent slope of is 2 and negative 4. That'll be the first one. Well, you do. You're getting it. You don't have a choice. So, m tangent, I would go m tangent for 2 and negative 4. The only thing I have to plug in is which? The x, because the y doesn't exist. In implicit differentiation, which we're going to do later, there's going to be x's and y's involved, and you'll have to plug in both. But for these ones, we don't. So we go 4 minus 6 times 2, and we get negative 8. So that is the slope at this point. So at this point, at 2 and negative 4, I'm going to have a slope there. That will get me the tangent slope, negative 8 over 1. So I would go down 8 over 1, down 8 over 1, down 8 over 1, or up 8, left 1, right? So my tangent slope would be on there. So if I go up 8, this is over 1. If instead of going down 8, right 1, I could do the complete opposite, we said, correct? And why is that? We discussed this before in period. Because the negative 8 could be a negative 1 and a positive 8, correct? That's why I can go the opposite way, because that negative sign can move to the bottom. So that's how we can go up 8 and left 1. So let's try it. We go up 8, 1, 2, 3, 4, 5, 6, 7, 8, left 1. And then I would connect those with a really straight line. Tangent means touches in one spot. Does that touch in one spot on that graph? It doesn't. It touches perfectly. It's the best graph drawn. It is completely perfect. There's nothing better than this. Yeah, it's just kind of a little shaky. So do you see how it goes through one spot? Right here. Here's where it's tangent. It touches there, and then the line runs along. It could run along it, but it can't touch it in any other spot. That would be a secant line. Okay? So this is my tangent slope. Okay? But what if I ask for the, yep. I just picked 2, 4. 2, negative 4. They'll give you a coordinate. Yeah. So if they don't give you a coordinate, we have general tangent slope. That's as good as it gets. If they give us a coordinate, then we can get a specific tangent slope. So with this general tangent, I can pick any coordinate off of that graph, and I can get its tangent slope like that. Because now I have the general form, like we did in grade 11 when we would ask for the general form of an arithmetic series or sequence. Okay, Now, sometimes they ask for the tangent slope, sometimes they ask for the tangent equation, the line of the tangent. The equation is the line of the tangent. Now, this is the equation you can use. You were taught this in grade 11, and by grade 11 I mean grade 10. Y equals mx plus b. This is slope y-intercept form, correct? Why is it called slope y-intercept form? Because m is your slope, b is your y-intercept. Crazy how they call it slope y-intercept form. Okay, so we can do that form. And which form are we going to use? We're going to use the one that matches the multiple choice. So sometimes the multiple choice is in slope y-intercept form. Sometimes the multiple choice is in point slope form. Now I want to show you how you get point slope form. So if we use our slope formula, okay, our slope formula is y2 minus y1 over x2 minus x1. We agree? If I only had the point, 1 point, and the slope, the y2 and the x2 would just stay y's and x's, correct? So technically, could I look at it as this? M equals y minus y1 over x minus x1? Could I not? Sure. If I want to get rid of, if I don't have 2 points, I have an actual slope this time and a point. Whenever we've done it in grade 10 and onward, we've wanted to find the slope. So we need a y1 and a y2 and an x1, y1, and x2, y2. We need 2 coordinates, correct? But now we don't have 2 coordinates. We have a slope and a coordinate. Yes? So our y2s don't exist. Our x2 doesn't exist. We don't have a second point, but we're going to come up with an equation. So what they do then to get this point slope, it's called point slope form, because you have a point and slope. You can bring this x up. So we go x minus x1. Right? I can bring it up by multiplication, can I not? Yes? So point slope form is this. They just write the y's first. So point slope form. When do we use each of them? Well, this one when we have a slope and a y-intercept, because it's slope y-intercept form, right? This one we have point slope form. So it's going to be y minus y1 equals m times x minus x1. Do you see how it's just the slope rearranged? It's just the slope formula rearranged. That's all it is. It's that x over x brought up. Now some people are like, I don't remember if it's y or x's, if it's y's in the numerator or x in the numerator. Well, think about slope. It's rise over run, because it's like when you get out of bed in the morning. Do you rise before you run, or do you run before you rise? You rise and then you run if you're late. If you run and then rise, you're just literally running in bed. You look foolish. That's what you are. You're just like getting a good workout and then you get up. Like, it makes no sense. So when you get out of bed in the morning, if you are late, you are going to rise and then you are going to run, which is what slope does. You're not going to run and get a workout and then rise and then just stand there and go, oh, too late, and then you rise. All right. Now, which form do we use? We use the one that the answer exists on. A lot of the time it is actually point slope form, which is a lot faster in this case. Why is this one a lot faster? Because you're given a point and slope. It's crazy. So, this is x1, this is y1, that is m. We agree? Let's fill it in. Y minus a minus 4, so plus 4 equals negative 8 x minus 2. And they will leave it in this form, guys. So it's blatantly obvious they want it in point slope form because the answer is in point slope form. Okay? Could you switch that into y equals mx plus b? Sure. Distribute your negative 8 through, move your 4 over, and you have it in that form. Right? That's the equation of the tangent. So this isn't as easy to see and draw. We agree? But if they ask for it into multiple choice, that's done. But if we want to actually draw it, it needs to be in y equals mx plus b form, because that's how we know how to draw it. We agree? So we're always going to practice putting it in both forms, because they could ask for either form. Point slope form or y equals mx plus b form. Y equals mx plus b is easy to do as well. You have a y, an x, and an m. So your y if we use y equals mx plus b, your y is -4. Your m is -8. Your x is 2 plus b. Then we're going to add 16 over. And b equals 12. So my slope y-intercept form is y equals -8 x plus 12. Do you look how mine doesn't even go through a slope? Or it doesn't go through a y-intercept yet? Because the y-intercept of this line should be 12, which is way up here. So should I, if I actually get this equation, should I keep 1, 1, 1, 1 as my scales? Or should I probably have changed my scales to 2? 2. Do I have to change the x and the y to the same scale? No, I could have left my x's as 1s. That's completely fair. If I change them to 2s, it would be a really squished graph. So I would have kept my x scale at 1, and I would change my y scale to 2. So I'd be able to draw that 12 y-intercept and then go down 8 over 1, down 8over 1. Okay? So which form is better? Well, this form's better if I have to draw that line. I have to sketch that line. This one's better. I go to my y-intercept of 12 and follow my mapping of negative down 8 and over 1, and I can sketch that whole line, right? That's there. And that line would be a lot more accurate if I actually used the line that I found. If they want this form, it's because it's multiple choice, and they have it in point slope form, and you have to have it in point slope form. Okay? Yeah. So could we find numerous tangent lines on this graph? Yes. I want you to give me the point slope form and the standard form at the coordinate -1 and -7. And then I want you to sketch it. Oh my gosh, stop. So I want it at -1 and -7. And I want you to sketch the line on there. I want both equations. So our general slope, m tangent, is 4 minus 6x. Now this one we actually have a new x, it's -1. So we're going to get 4 minus 6 times -1. So what's my tangent slope of this one? 10. Now if I want to do y minus y1 equals m times x minus x1, what form is this?
Point slope.
Point slope, because what do you need to do it? A point and the slope. It's crazy. I know. It's not like it's like Samurai's method or something, you know, like Samurai made it up and then decided. No, it's point slope. Yeah. All right. I don't know why I thought Samurai, but I did. Okay, cool. So we have y minus a minus 1, 10, x minus a minus 7, and that would be point slope form and we'd be done. Yeah.
Like a 5, like it's a fraction on a fraction on a fraction on a fraction on a fraction. It's a 5-way fraction. And the center method is just
I don't know what you're talking about. Been totally good. I didn't change anything. Look, it's a 7 the whole time, and then this is a 1. All right. Now, we want to be able to sketch it. Guys, it's really hard to do stuff and not make mistakes if you're the whole time.
She's blaming us.
I am.
Yeah, wow.
I still have a bit of a heart palpitation problem due to the snake of yesterday. I'm not going to recover from that. Oh, it was so bad. Okay. It was not okay. It was bad. I did not feel good about myself. I almost had a panic attack. It was okay. I did go under
That
it.
was a wooden snake. What would happen if like someone brought in like say a gardener snake from like their backyard?
Dude, I want to
Like not right now.
I would make sure you got expelled. That's what I would do. I would do everything in my power. I wouldn't. Actually, I would. I think I would. Yeah. Or I'd quit. One or the other. Okay. I don't do well. 10x plus 3. Okay. Which form is better?
The one on the right for sure.
Whichever one they asked for. Which one's better for graphing? The one on the right. So we're going to draw this one. It is a slope of 10 and a y-intercept at 3. So 3 is like my starting point. So I'm going to start at 3. And then I can go up 10 and over 1, except I can't. So I'm going to go down 10, left 1. Why can I go the complete opposite direction when it's at 10?
Because you're still using the words.
No. Because this could be 10 over 1, or it could have been negative 10 over negative 1, correct? That's why you can go the complete opposite direction. So we go down 10, right 1 from 3. So down 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Shh. Lost my spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1. Weird. It lands right on the point. Shocking, I know. And then, this is on, oh gosh. This is, on a piece of paper, you better use a ruler. I don't have that option. It's bad.
It's like worse than mine.
I don't believe that to be true. All right. So do you see how there can be tangent equations to every single different coordinate? Yes, right? Okay. So, I want these handed in tomorrow. I'm going to give you 2. I want you to, these are going to be handed in tomorrow for marks. There's 2 of them. I want you to determine the equation, like the slope of the tangent, the equation of the tangent, and sketch the graph with the line of the tangent. Okay? There's 2 of them. These are the 2 that I want you to do. So I want you to do number 1 and number 2.
What do you want us to find again? Well, you said there's 3 things that you said at a very small, long time, so.
I want the slope. Tangent slope. I want the tangent equation, and I want you to graph it just like we just did.
You have graph paper?